Guys, so I'm going to start with pig today. So just like Hive, pig is an alternate way of running a MapReduce code. We don't have to be complex Java coding. It's a high-level data flow language, which is easy to understand and easy to learn, and we can apply or run any transformation on HDFS data. So just like Hive, pig is also an alternate abstraction on top of MapReduce framework. So when we write pig scripts and substitute and submit it, it actually converts those data flow language into MapReduce code and submits a MapReduce job behind the scenes. So, so pig is similar to Hive, but both can serve as a different purpose. Hive is more like a SQL. Pig is more like a data flow language. So it means we can do more. There's more flexibility doing more transformations using pig, which it might be difficult in Hive. And everything can be done in Java, but it depends. Java is getting complex, and if you don't know Java, pig and Hive are very good alternatives. So pig uses runs on the client machine and turns pig Latin script to the MapReduce job. So it actually pig can be submitted on the client machine, and it actually goes to the cluster and can submit the MapReduce jobs. See, MapReduce jobs will be submitted to the cluster. So on the high level, pig is similar, and the next slide we'll see the difference between a pig and a SQL. So SQL is a declarative language, and pig is a data flow language. So data flow language is in pig we will have a relations which you will see in next slides, but those relations you can take that flow of that relation, output of that relation, and use that relation, and anywhere in the pipeline all the way at the end you can use the output of that relation as an input of another relation. So it's a data flow language which can flow from top to bottom. It flows, and it can be used. It's actually the relation output of one relation can be given as input to another relation in that flow. So in SQL, schema is required. That means you have to specify when create table statement. You have to specify all the schema, what data types, columns, and everything. And without the schema, you cannot read the underlying data. So pig schema is created on runtime. You don't have to specify beforehand, but it's created on runtime and it's optional. If you don't specify the columns or anything on the file, it will take some default values. But you don't have to have a schema before reading the data. You can read the file directly, and it builds the schema on runtime. So RDBMS SQL is used for low latency queries, such as if you want to read one record from the whole table, you can just submit the low latency files like you do, like ID is equal to 1 or 2, like if you have 100 million records. So RDBMS is very fast to run the low latency queries. Just do select star from table where row ID 1 or order ID 1. But in pig, coming into pig, you can also submit those values in pig, but it will take longer time.
Sorry to interrupt. Are you?
Oh, okay.
Yeah, same thing with me.
Yeah, Karthik was the one who said like he was not able to see. So
can you see it now?
Yes, thanks you.
Okay. So SQL is low latency queries done in pig. It's a batch processing. Low latency queries also we can also run in pig, but it will take longer time. So they call it as no random reads or writes. That means random means only out of like 1 million records, you're trying to read only one record. That's a random reads. Or writing only one record back to the HDFS location, which is not possible using pig. So batch process reading is easier and faster than the random reads and writes. So Hadoop is actually good for batch processing and the ETL process. Random reads and writes, SQL is very good option. So submitting these jobs, I'll explain you more. You can submit jobs using local mode, MapReduce mode, or grunt shell. I'll explain you more when we're doing practicals. So data types. Data types in pig, if you see this, these data types like int, long, float, double, char, these are like common data types. Everything can be used in pig. Apart from this, there are complex data types which are called tuple, bag, and map. So tuple is nothing but it's a collection of fields of any type. So this whole thing makes a tuple, and like XYZ, ABC, and 11, 111, it makes a tuple. So this is nothing but a sequence of fields of any type. So when I say any type, this is int, this is string, this can be anything long or float. So a sequence or a combination of fields of any type is actually makes a tuple. So in pig, you can pass or read tuple, and there is a way to read tuple also, like second field, third field. You can there's a way to read tuple. And another thing is called bag. Bag is nothing but a collection of tuples. In here, if you have multiple collections of tuples like this, then that becomes a bag. So these are all complex data type that you can use in pig. And there is another called a map. Map is nothing but a set of key value pairs. That means uh, we have to specify a key, and the value is specified next to it. Key must be an array and values must be in any type. So to read map, you can read the value by passing the key value. Then the output we can read it as a value. So this becomes three types of the data types: tuple, bag, and map. As you see in here, tuple is a collection of different data types. Sorry, collection of atoms, like fields of any type. And then bag is nothing but a collection of tuples. And then map is a set of key value pairs. So these are data types in pig. Okay, now comes the important part of it. So pig Latin. Pig Latin is nothing but a language. That's a pig language. It's a statements that you can that we can run for our transformations or any calculations or anything to access the HDFS data. That's called pig Latin language. So there are very handful of statements that we have to know in here, which we will be using most of the times. So for example, load statement. Load statement in here actually reads data from the file system. So for example, let's say student is a file, student.txt. So we are loading student.txt file. We're loading into a relation called A. And while loading it, we are telling pig that use a storage called pig storage, which is an inbuilt storage defined for pig. What it will know is it will know by using pig storage, it will know what the file is, how to use the file. If it's by default, it uses, I think, tab delimited. So inside the file, if the row is tab delimited, the first three characters, we are saying that use as first character, first field as name, second field as age, third field as GPA. So we are loading student with these three fields into relation called A. And after this relation is built, you're going to the next relation, saying that for each relation that we got it, for each record in that, just generate name. This is nothing but select name from this relation. So for each record, all it's doing is it's pulling the name from that records. I'll show you all this in practical. This is very high level. So load statement is reading data from the file system. A series of transformation statements to process the data. And then final to put the output on the screen, we have to use a statement called dump. Without dump, it will not actually put any output. It will just keep on creating the relations and store the relations. But dump is the statement which is used to view results, and store is the statement to save results. Dump is it will dump it on the screen. Store means it will store to a file. So for in this example, if you're loading student using this storage, then for each data, then generate name. So we can actually think, if we have an example, we'll go ahead and see this example. So let's see if I have. Let's load this data. I have a. I'll create some data sets. So in the data set. So I have a data. Let's go ahead and create a simple data set of. Okay, so let's go ahead and create simple data sets. Test dot text. So we will say that 1, comma, then you'll say first name Shiva, and then we'll say department something finance. 2, we will say let's say Karthik, and then finance. So we'll create this 3 wake and then say research. So let's save this sample file and see. Let's try to read this from big. So let's read it. Okay, so let's say I'm connecting to pick. So now I'm connected to the grunt shell. Here, let's cd. So cd desktop. Our file is this test.txt. We will move this file test.txt user Shiva pig. Okay, now we will do pig. So here you will say a, then say is equal to load, then user Shiva test.txt. It's test.txt, and we are using pig storage is inbuilt function to see what delimited. So that's in there we are using comma delimited. Let's see if this works. As ID.
Shiva, do we need to put the dump?
No, dump is at the end.
Okay.
only when you want to print the results. Now if you can put dump, but it won't show you. Dump is nothing but it will run all the, once you execute dump statement, it will actually run map reduce jobs all for all these relations. When we write these relations, it won't actually execute any map reduce job. It will just checks for any errors, schema errors, and it will just go into the next relation. But only when you use dump, that's when it physically it executes map reduce job.
Okay. Okay. Thanks.
Name, I will say array, and then what else we had is department. User Shiva pick. They have to give the complete statements. You're passing a comma as a delimiter in the file, and you're saying that you're using test.txt and you want 3 characters. Now let's say dump A. Now it's actually going to kick off the map reduce job. 0% complete. So it's kicking off map reduce job now. So until you kick off dump, you do dump, it's only going to do a logical design. It's not going to do a physical plan. It's a map reduce plan. So let's see that. After it's completed, we will do for each statement also, and then go to the next step. Okay. Now it printed this way the values. You're dumping all 3 values. So let's say I want to just dump the first name. Just read the first name, this 1, 2, 3. What you do is you will put that, always use the relation. Without relation, bit doesn't exist. So we are using relation, and then after relation, you are actually use the dump or store command to execute it. So in relation, let's specify. So this is data flow language. You can actually use previous relation to execute the current relation. So now you're saying that for each of previous relation, what is previous relation? A. And you're saying is generate. What did I use? ID. So for each A, generate ID. Okay. So let's see if we have an ID. Generate ID, yeah. So when we run dump, it will execute all the previous relations. So now when you say dump, it has to execute relation A and then execute relation B, and then gives the output after that. Now we dump 1, 2, and 3. So this is dump statement we saw. So we can also see, so now we saw dump, and like dump we have some big Latin statements. First let's go through the list of statements that we have, and then we can execute later in later classes, but let's go to the different statements that we can use. So for big Latin statements, what we have for loading and storing, we saw that we can use load, we can use dump. So load is for loading, dump is for dump, and then we can also use store. Store, dump, difference between dump and store is dump will dump it onto the screen, store is to store it on the in the file. So dump is to print a relation on your screen, store is to store a relation in a file on your HDFS file location. And then we can also use some filtering commands. So for example, what we have is we have a command where you can use as a statement where you can use as filter, which we can use filter. I'll show you in here in the example, but let's go through this first. Then you can do distinct to remove duplicate records, and then we just saw for each generate, right? This is to it's to show or remove fields. So let's say if you have like 10 columns, you can say that for each generate only column 1 and then column 2. So this is to add, this is to remove the fields that is not required from the relation, and then show the remaining fields. And we also have something called sample, which will select random sample. This is filtering. There are more, but I'm just telling you the very important ones and the very high level ones, which we're going to use it most of the times. We have some grouping functions also, and in grouping functions we can just do group by, which groups the data in single relation. And we also have, I think, co-group. Yeah, co-group also works. It groups the data into 2 or more relations. And like any other language, we have joins also in here. So for joins, you can just do join, and in join also we can use multiple, like replicated. I'll go through what that means, but replicated, skewed, these kind of joins. You can specify what join you have to use it, but the statement for it is simple join. And if you want to create cross product, you can use a statement called cross, which creates cross product of 2 or more relations. And for sorting, as it is, you know, sorting will be like order by. And like for combining, you can use union, just like any other database systems. And to split the data, you can use split. Split means in this AB3, you can say that split into 2 records. Like you can split it into a file 1, splits relations into 2 or more relations, or split into A, and or you can split A and B depending on the condition. So this can split into one relation, this can split into another relation. We'll do all these practicals anyways, but this is the high level. These are the like 10 to 15 statements. If you know how to use it, that covers the most of the big statements. So we will see filter commands, store commands. Let's do some quick filter commands. See if it works. So now we have a relation A and B. So from if we do dump A, what did we get? We got all the values, right? So let's filter A by ID is equal to 1. So we want to see the records only that has ID is equal to 1. What we will do is we'll create another relation where we say that C is equal to filter A by just id is equal to 1, and then it should put that we should get values only for the one which says id is equal to 1. And then we will do store and try to store the values in HDFS location. And then actually I'll show you some debug statements also. Okay, now we did dump A. So if we do now let's go ahead and do a filter statement. For filter statement, you're doing C is equal to, what are you doing? We're doing filter, you're doing A by what filter you want to apply. We want to apply filter A by ID is equal to 1. So now I'll show you. Let's see what describes what debug statements we have. So what if you want to see what is exactly the relation behind this C? You can simply do describe, and it will tell you the relation behind that. So what we are doing is filter A by ID is equal to 1. That means after filtering A, you'll still get 3 rows. So that means describe statement is showing that when you see the output, when you dump C, you will get 3 values: ID, name, and department. This is how you can do describe. Describe is very useful to see what relation this has to describe it, like to print a schema of this relation. So this is a schema of this relation. You are printing the schema. That's used for describe. So now let's see dump C. Oh, actually we wanted to do store, right? So let's do store later. Let's see after this. Okay, so now after filtering it, you saw it only printed 1. So now what if you want to store this data into some table? So you want to store C data into, you want to store Shiva, okay, and you're saying that store into a folder called C. Store will also run a MapReduce job, but it will store into that location. It will not dump it onto the screen. It will store into that location. Okay, now it's completed. Let's see. Let's go to that location user Shiva pick C. Now let's go to that mapper and see the output. we can see the output in here. So this is how you do store command. So we saw load command, dump command, describe command, store command. There are other functions like just like RDBMS, you can use functions on any of these, like average, concat, sum value. This can be used by default. And we have macros in Pig also, which we can use it. So we can define a macro. It's nothing but you can use it as a package, and then you can reuse that package in the Pig statements. So we'll see macros and functions in next class. So today's class, this is enough.